I invite Mr. Arjun Sundaresan, Chairman of GCW Alumni Association, Bangalore Chapter, to talk to you for a few minutes.
Thank you, Anu. Good evening, friends. Arjun here, Chairman of Government Engineering College, Wayanad Alumni Association, Bangalore Chapter. Hope everybody are staying safe and hope things will get settled on soon. Few of us met last week, but still, I just wanted to introduce ourselves before we start the session. Our chapter, Bangalore chapter, officially started 4 years back, and as part of our commitment to the college, we used to conduct a seminar session in the college premises. We used to come with the industrial expert from different aspects of tech industry, where the hardware, software, etc., and to give the session to the students. This is supposed to happen this year also, but because of this COVID situation, we are basically not make it physically. And we decided that let's do via online. As I mentioned last week, we are not planning for or not two sessions. We are already planning for a series of sessions. So today the topic, introduction of 5G technology and how it's influenced our life. So today's session is going to taken by Mr. Ahamed Shameer, the main pillar of our Bangalore chapter, who represents the first batch of our college, and also he has been mentor and guide us for all of us actually. So Mr. Shameer, who has passed out GC Wayanad in 2003 and has pursued his MBA from Birla Institute of Technology and Science. He has been mentoring us not just with academic knowledge, but he also with his experience of 17 years of experience in IT industry. He has worked many leading companies like Nortel, NetApp, Cisco, and currently he is working as an engineer manager in Mitel. He started his career as a software engineer. It's not so easy in the 17 years to become a engineering manager. Because of his hard work, he become. So he has experience on security, storage, or domain, etc. Uh, uh, See, even we are, as I mentioned, this 4 years back we started this alumni. He was the one person with us for starting this alumni, right? So personally or officially, for me, actually, anything for my my career or my personal stuff, I used to connect with him always for a guidance. And for me, he's a very special person in my life. All right, so he's a patron of our alumni chapter. So over to you, brother. Thank you, guys.
Okay. Good evening, all, and thank you, Arjun, for giving me a fantastic introduction about me. I don't know whether I am, I am eligible for that great introduction, but thanks for that, and thanks for IEEE and Government Engineering College, IEEE Students Wing, and GCWA to give an opportunity, for me to give a session to you guys. So I am privileged and I'm very much, honored to have a quality time spent with you guys for next solid 45 to 50 minutes. It'll be fantastic, and I'm sure. On the side note, I'm sure you're staying safe and healthy. Okay. So without no further ado, let me try to share my screen and we can start. Okay. I think my presentation is little loaded, but I think I need to little bit go faster. So let's see. Okay, and let's make it like first 45 minutes. We'll have the session, and the rest of the available time, whatever we have, let's get it to the Q&A. Yeah. So let's go with that mode, and let me see whether I can present my slides. Okay, so let me see the window. Just give me 1 minute, guys. I'm not that much familiar with Google Meet. Let me just try. Are you able to see the screen, guys?
Yes, sir. Yes, it's visible.
Okay, sounds good.
Yes.
Okay, is my I just opened another notes to take a note. Is it not? It's not obstructing the PPT, right? It's coming good, right?
Yes, yes.
Okay. Okay, so let's start. So again, good evening all once again. So I think Arjun has given a good introduction about me, and thanks for giving that fantastic introduction. As you were saying, I have worked in companies like Nortel, NetApp, Cisco, and multiple companies, and I've been in IT industry for almost 17 years in various domains: VoIP, data, storage, security. And I live in Bangalore. I've been working in Techno Park in Trivandrum, in Info Park in Cochin, and all in my earlier career. And then, for a few years I was in US, and then came back to Bangalore. For last some 12 years I'm in Bangalore. So that's about me. You can catch me on this email, and my LinkedIn profile is here. So if anybody wants to reach out to me for anything, please feel free to note it down. Okay. So let's go faster. So today, this is our agenda. It's all about 5G, right? Today, our talk is about 5G. But to talk about 5G, I think it's always good to go back a little bit on the history, how all those things happened last last maybe 50 years or so, and how we started from 0G to, or maybe 5G to, 1G to 5G, right? And then talking about 5G, and then 5G more, and how it affects our life. Okay, so let's jump into 1G, right? Guys, just one thing, I want to know the feedback. Is there anything hindrance? Is it coming properly, the slides? Or I'm opening two windows in my screen. Hope you are not seeing two windows here.
No, no, it's perfect, sir. We can see the presentation.
Okay, cool. So,
Hello, sir.
Sorry.
Hello, sir. Sir,
Yeah.
please do the slideshow.
Sorry.
Make it a slideshow. Sir, please make it a slideshows.
Okay, I can try that. Is it okay now?
Yes, yes, yes.
Is it coming good? Okay. So,
Yes, sir.
okay, cool. We have been using different wavelengths of electromagnetic radiation, right? All those things, right? 1G, it started in 1980s, very, very long back, like 40 years back, right? It was completely analog system, and the speed was 2.4 kilobits per second. I'm talking about, a person using, it's called brick. Actually, those phones was called brick because that heavy was it. And, and to charge it completely, full charge, right? There was some stories around it, like people used to take almost like 24 hours to charge one full battery of those 1G, mobile devices. It was that heavy. It was completely analog. It was first launched in US. There are different versions to it. Some people said it was first launched in Japan, and some people say it was first launched in US. Both are correct. It was different versions of 1G. Okay, and it was having very, very basic calling scenarios, like just call and that's it, right? That was 1G. What happened was, even before this, right? 1G, it was 0G, which was nothing but our telephone system, which is again analog, or fixed line connection, right? So then what happens in the 2G? 2G is after 10 years. So if you see the history, every 10 years there is a change. It's not sudden change, it's a gradual change. But you can say that after every 10 years, you can call it as a generation. So for 1G was 1980s, then you can call 2G as in 1990s, right? So across from 1980s to 1990s, that 10 years, there are a lot of advancement happened, and that's the time I started using mobile phone. That was like 19 have seen mobiles, mobile phone, not used one, but I didn't own any mobile, but I started seeing mobiles in my ninth standard, 8th standard, and all. So now you can calculate my age, I think. So the speed was just 64 kilobits per second, and the main difference was, it went from analog to digital. That was the big difference. I want you to, I want me myself to go through the frequency, how it was transitioned from one base station to the endpoints and all. But it's too much, too much to discuss. So I'm not going through those, in depth, technical things. But I think if we get a chance, we can talk in our Q&A session. So the first text message was introduced in 2G, where we all call it SMS, right? And there was a limit of 160 characters limit for the SMS, right? All those things happened in 2G. So that happened, and the base. Again, I just want to reiterate, the base change was, it went from analog to digital, right? And then happened the 3G. So that is where our iPhones and all got launched. That was in early 2000s or late 1990s, where the transmission speed went from 125 kilobits per second to 2 Mbps. So I remember, Apple company was introducing their phones, saying that they support 2 Mbps per second transmission speed and all. I mean, it was fantastic at that point of time. And the big difference was, it supported MIMO. Again, MIMO is a technical term in telephony, in telecommunications, which is called multiple input, multiple output, where the same frequency can be used for input output at the same time. Again, there are a lot of technical things to it, how we are achieving that, and how how we avoid the interference of the signals when you use it at the same time and things like that. But there are ways to do that, and that was the big difference we achieved in 2000s, right? Little in the earlys of 2000s. Okay, so and the other big difference, before I forget, was all things started becoming. I said 2G was digital, 3G was again digital. Obviously, everything is digital after 2G, but 3G was more into the packet-based transmission, where it's no more analog anywhere, even voice or even text. So 2G was analog and then digital. Here 3G is everything digital, everything is packet-based transmission, where you will have headers and things like that in the packets, and destination, source address, all those things, and then the payload in the in the packet. So it all became packet-based transmission. Okay, so now comes the 4G, which we all know. We are using 4G now. This is our generation, or yeah, maybe we can call it as our generation, or maybe your generation. Right, it started developing in 2010. It is faster and more reliable. It is having speeds at 100 Mbps second, high performance. We started supporting EC roaming and low cost. Now you can say that nobody charges anything on voice, right? Everything is data, right? So from that, you must be able to understand that from 4G, everything is IP based. There is no more voice packet. It's all IP based. You will have IP address allocated to your endpoint, and your communication starts from a end IP device to either base station or the end or the destination endpoints. So what is the difference was, if you see all those history from 1G to 4G, right, how they were able to increase the speed of the transmission, right? That's a question, right? That happened just because they started using the frequency ranges that they were having, they were using for the mobile communication, right? They were starting with 700 megahertz. Initially, was 700 megahertz was the operating frequency, and then they started 1.2 gigahertz, and then 2 gigahertz. And the more you go and then start using the more high frequency transmission, operational frequency, you get more, speed, you get more bandwidth, you get more transmission rate, right? That's one of the ways, all those technologies were able to achieve more, transmission speeds and performance and things like that. So, so that we are now in 4G, or we are almost getting an end of 4G, right? Next one, what is next, right? So before I go to the next next era, I'll not call it as generation, I'll call it era, where you can see this. Before I go, I just thought of comparing with all the first generation, second generation, third generation, fourth generation mobile, nothing but first 1G, second 2G, 3G, 4G. You can see the difference. If you want to read it, just glance through it, it'll be great. But you can see that in the operational frequency, there is one row. I think somewhere in the down, you can see that the frequency is increased from 800 megahertz to 900 megahertz to 1800 megahertz to 2100 megahertz. So this frequency started, they started using more high frequency bandwidth, right? Spectrum. So what's next, right? As I told, every year we have seen the change, right? But 5G is not a change. 5G, I don't think it's a change. 5G is an era. 5G is a complete infrastructural change. I just want to give an example or analogy with 5G, with something that we already have. When we started, when electricity was invented, right? We were not knowing how far we can use the electricity to for improving our life, right? We don't know how the people who just invented electricity didn't know what's the applications of electricity, and we now know that electricity is used in all the applications, right? 5G is similar, right? 5G is an infrastructure given as a technology. Now it's up to the the engineers and to the human beings that how that infrastructure can be used for the future. So it's not just a change. It's a different, altogether a different era, right? So let's call 5G as an era. So there are different when you hear 5G, right? A lot of people say that just you can get lightning speed, you can download the Netflix, YouTube videos in just 1 second. Some people say that you can connect to n number of devices. So there are different ways that you can call 5G, right? I just want to play a video to just I think 3 videos to show you the 3 perspectives of 5G. Okay. So I'm just trying to share the screen here, and then let's see whether I can successfully present it. Okay. Are you able to see the screen?
It promises to transform our lives in all kinds of different ways. But what is it exactly? It's often described as just the next step in the pursuit of an ever faster network. But in reality, 5G is much, much more. It's an entirely new technological foundation, purpose-built to support the next great wave of life-changing digital advancements that will be enabled by our smart and connect future. From the safety and environmental benefits of autonomous driving to dramatic breakthroughs in artificial intelligence via machine learning, a whole new era in healthcare, to a smart and connected revolution that will transform agriculture, cities, our individual homes, virtual and augmented reality, and even the Olympic Games. Every one of these promising new breakthroughs will be built on the common foundation of 5G, all of which puts Intel and our partners in a unique position to build the 5G future together.
Guys, were you able to hear the audio also?
Yes, sir.
Okay, so I'm coming back to my slides. I just want to you all to hear that 5G introduction about Intel. I'll come back to my presentation. Are you able to see the screen? Are you able to see the screen, guys?
Yes, sir. We can see the screen.
Okay. Sorry, I just want to make sure that everything is proper. So, what is 5G, right? You just saw the video and a kind of a trailer that we see normally in movies and all, right? It's an infrastructure which will be given to the world, and it's up to us to use it, and then the applications on top of 5G is infinite, is unlimited, is like so much exciting that I'm looking forward to it. It's too much. So what's the next? I just thought of putting what is there in 5G in 5 bulleted points. The next major phase of mobile and telecommunication and wireless system. That's what you can define it as 5G. 10 times more capacity than others. Others means the 4G and rest of the other technologies. Expected speed up to 1 gigabytes per second. That means you can download a movie in 1 second. That's it. More faster and reliable than 4G, obviously, and low cost than previous generations. So this is what is 5G in a very, very high level. Okay. Now let's look into 5G in pictures, right? You can see that everything becomes smart. Like our mobiles are already smart. Our TVs are getting smart. Our fridge is smart. Our traffic is getting smart. Our car will be getting smart. Even the electrical grids will become smart. Everything will be smart, meaning they will be connected, and there will be applications built on it, and you can control from anywhere. Now, how this is possible, right? People will ask, how this is already done, right? We are already having smart appliances in our home, which is our Wi-Fi and which is our 4G. Now, what's the new thing here? The new thing here is you don't need to have Wi-Fi at home. You don't need to have anything. It's just as you have 4G, right? It will be available inside the home, and it will be connected, and it will be so fast that you don't need to worry about the bandwidth. You don't need to worry about the latency. You don't need to worry about the performance. Everything is connected, right? So the smart city concept, smart houses concept will just emerge like anything. You can, if you see if you watch the global happenings, right? It's already there. Some of the cities are already implementing 5G, and it's already started. So this is 5G in pictures, right? What it delivers in 5G, right? Increasing wireless capacity 1,000 times, meaning if you are able to download 1 MB per second, now you can download 1 GB, right? 10 billion people can connect. 7 million people can connect at least, right? Meaning what? Everybody can connect, right? And and the bigger part is machines will start getting connected. It's not just human beings or smart devices. Each machines, each sensors, everything will start getting connected. Like, a bulb in our home will be connected to the internet. It's nothing but IoT. So the current 4G technology will not support that many number of devices to get connected to the grid. 5G allows it. 5G allows 7 trillion machines or endpoints to get connected to the grid. The next thing is, it saves energy. You don't need to have bigger batteries for 5G. Currently you can see some of the changes happening where you need 5G and all. That's because you need bigger battery. That's because the antennas are not available that much, so you need more power to get the signal. But when it is fully introduced and fully network completely is established, then you are saving a lot of energy. You don't need that much power. And the last but not the least is the very big important point about 5G. It is nothing but latency is very, 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 very low, meaning it's almost like zero. That means if I want to if I'm a surgeon and if the patient is in US, I should be able to make a surgery from India and the patient is in US, where I'll be having some control devices in my hand with all the equipments. And if you cut something at that point without any latency, that particular part of the body will be cut, or whatever is a surgical procedure there, right? It's that fast. It's zero latency. It's not possible now. 4G, you can't do it, or any network currently available, right? We will not be able to do that kind of mission critical applications. So that's what 5G delivers, right? Let's little bit go into technical side of 5G and 4G, all those things. In this diagram, you can see light green area where that shows about the 4G technology and how it delivers, and the dark green area is the 5G. Now, if you see the top right, user experience data rate, 4G gives 10 megabits per second, but the 5G gives 100 megabits per second. Spectrum efficiency is 3 times. Mobility is an interesting thing. If you see the rightmost part, right, bottom rightmost, you can see mobility. It says 500, meaning if I am in a train and the train is moving in a speed of 500 kilometers per second, I will still be able to connect to the 5G network without any issues. We all face the issue, right? When we are in a train or in a car, we lose we will still be having the voice, but the data will not be that fast, right? Or, we will get disconnected. In 5G, it is assured, it is guaranteed that, mobility where, the device, the endpoint, if it is moving at 500 kilometer, maximum 500 kilometer per hour, you will still be connected. And all those things I am talking about is the minimum requirement. It can go up to max. The max is unlimited. Whatever we are talking about here in this picture is the minimum requirement for 5G. If you have all those things, 5G is there, right? Latency, as I said, it's near to zero. You can see 1 millisecond is the latency minimum requirement. It can go up to near to zero. Connection density. It says 10 raised to 8, which is almost like 1 million devices per square kilometer you can connect. That means within 1 kilometer square area, you should be able to 1 million devices can be connected to the grid. That's like too much. You would have seen this image, right? It's self-explainable. So this is what the design targets for 5G, right? If this is achieved, all the engineers, all the big companies who is leading the efforts, like Intel, Verizon, Intel, Qualcomm, Huawei, Ericsson, Nokia, these are the few companies which is pioneer in telephone industry, and all those companies are working from last 10 years to get into these targets, right? Isn't it exciting, right? So how this is achieved, let me take a note of the time. How this is achieved, right? We should little bit dive into the technical part of it. There are a few things which, again, there are a lot of technical things. It's too difficult to get into all those things in 1 hour, but it's very high level. But let me go into a little bit inside how we are achieving all those 5G, big stories, whatever we spoke, right? What are the technologies behind it, right? So these are the ones, have very important ones: millimeter waves, small cells, massive MIMO, multi-input, multi-output, beam forming, full duplets, and the list goes on and on. But I just thought I'll put this fine. So what is millimeter wave, right? If you see this diagram, you can see that this is the spectrum, the complete spectrum of the frequency, which includes, the visible light frequency also, right? Now, till now, 4G, right? You can see that in the left corner, you can see 1 gigahertz to 6 gigahertz is the frequency range that we were using till now, which includes 1G, 2G, 3G, 4G, satellite communication, radar communication, even air traffic communication. Everything is within 6 gigahertz, frequency range. Now that is completely, used, right? It's like crowded. Lot of devices are connected to in that particular range of frequency. We will not be able to connect whatever we're talking about, 7 trillion devices and all in that frequency range. And it's not faster also. It's a slow frequency, right? 6 gigahertz is faster, but when you start from 1 gigahertz, it's a big range, right? 1 gigahertz is 6 gigahertz. So the good thing is there is a good frequency spectrum available in the high frequency area. Like if you see this, the spectrum, it goes up to 300 gigahertz, right? So the spectrum from 30 gigahertz to 300 gigahertz is called millimeter wave. Millimeter wave is nothing but, it's high frequency. Like, the frequency goes like this. Low frequency will be going very slow. High frequency goes a little bit high, but millimeter wave is like, it goes very fast, and it will be the wavelength. The wavelength of the wave, it will be 10 millimeter to 1 millimeter. That's why it's called millimeter wave. So the proposed, or it's no more proposed, we are all started implementing. The 5G range will be starting from 27 gigahertz to almost like 100 gigahertz is the frequency range that 5G will be using, right? So what are the advantages of 5G, right? We all know that millimeter waves are used. What is the advantage, right? The main advantage is it's very faster. If the frequency goes very fast, right, you get that much number of data, right, very faster, right? You don't need to have big antennas for broadcasting, right? I remember when I was a kid, right, I was thinking that, why electricity was not sent wireless. I really thought, everything was, we have seen many things wireless, but the phones and all became wireless and all at that time, right? But the electricity was not wireless, and now we all know, when we go back to basics, right, the length of the antenna is inversely proportional to the frequency that it used, right? So if you want to propagate the electricity, which is 60 hertz that we have, right? 60 hertz is our electricity frequency. It needs at least kilometers of big antenna. So the antenna will be like so lengthy, like, it will be like 10 kilometers or 50 kilometers, and it's not practical, right? So I just brought this point. Why? Because if the frequency gets bigger, the antenna becomes smaller. if you see the old mobiles, right, 2G mobiles and all, you can see the antenna on the front, little bit of antenna, right? When it comes to 3G in iPhones or any phones now, you don't see any antenna because the length of the antenna got decreased. Now in 4G, you don't see an antenna at all, right? So when you see all those things, you should, you know that, antenna, the length of the antenna is somehow connected to the frequency, right? So now if you go to the millimeter wave, the antenna will be so small, you will not even see the antenna. So now if you see the tower and all, right, our telecom tower, whether it is Airtel or Geo or whatever, the tower, you see a big tower and all in some corner of the city, right? In 5G, you don't need to have that big towers. You don't need that big antennas. Because it's used millimeter wave, the frequency is so high, that means your antenna needs not be that big. There is an equation to it, which it's really out of topic, out of scope of this this session. I think it's really interesting to know. If you get the chance to read, please go back and then understand what is a connection between the length of the antenna and the frequency, right? So there are a lot of advantages. Now, is there a disadvantage? There are a lot of, not a lot of, but some disadvantages are there, which will come later. Okay, let us talk about good things about 5G. So I think this we already covered. What are the advantages of millimeter waves? The next big technology behind 5G is beamforming, right? This is very interesting to know. In traditional, 1G, 2G, 3G, 4G, right? There will be one antenna or towers kind of thing, and around that tower you will have the coverage, right? So if one person is standing in that somewhere around that tower, the frequency or the signal will go to every other place. It's like broadcasting. The signals goes everywhere, right? So a lot of power is lost. A lot of things are lost. Again, lot of discussions there. But 5G antennas, right? We can have beamforming, where a particular end user, if he's using mobile with 5G, the tower will only focus on that particular user and the signal will come there. That's called beamforming. The antenna is capable of broadcasting the signal only to that particular user. So what's the advantage here? There are a lot of advantages where you don't need to spend a lot of energy while broadcasting the entire space of the coverage. Interference between the two users will be less, where two users are together and then they are calling. Because it is beamforming, the signals will not get interfered between the two, right? Now there are a lot of things where when you travel and all, right, when you go to a place where there is less range is there, you get a lot of calls which that is called crosstalks, right? It comes to your phone. So those kind of things will not happen. So beamforming is another area where where the technology is coming up for 5G. Moving faster, the next important thing for 5G is small cells. As I said, the length of the antenna or the size of the antenna is indirectly proportional to the frequency. So the stations, the base stations, where the complete signal is coming out from the base station, it doesn't need to be so much big. It can be very small base stations. You will start seeing something like this. This is actually 5G antennas, where it is just on the electrical post, right? You don't need big towers for it. You will start seeing like what do you call our internet broadband connection. Some box will be there, right, in our electrical post. It'll be similar to that. Very small antennas. So what is the good point about it? You will get it is very easy to implement. It is very easy to install. You will get, if I just complain to my 5G provider that there is no connectivity here, very less range, they will just come and then connect a box near to my place, and then boom, you get 5G. They don't need to have big tower and all, right? So that's the very big advantage of small cells. Small cells is nothing but the antennas are called cells. I have some things which I can talk in Q&A session if you have time. Why we call cell phone, right? I was having the same doubt. Why the cell phones are called cell phones. Is it because battery? No, it's not because of battery. It's something else. We can discuss if you have time in our Q&A session. So what's the next technology that is there in 5G? It's about distributed antenna system, where I told, right? The antennas can be anywhere. It need not be in one tower. It can be in multiple floors, like you see in this diagram, right? The company has installed 3 antennas in 3 floors, so all the floors will get the signal. So it's called distributed antenna system, DAS. This we already talked about beamforming. 4G is like, the signal goes everywhere. 5G is beamforming. Because of this beamforming, we can have massive MIMO. MIMO is nothing but multiple input, multiple output, where we can have massive MIMO without much interference between the users, right? You can see the signal, the box there. 4G is just one, 5G is multiple, grid system. It's nothing but the number of antennas. It's not just one antenna. You can have multiple antennas, and one antenna can be, or 1 or 2 antennas can be, for 100 users, another antenna for 200 users, and things like that. We can do that because, the antenna will be very small, so you can have hundreds of antennas in one single box. Okay, and it's full duplex. I don't want to get into this traditionally, or up to 2-3G, right? Traditional radio waves are not full duplex, right? A wave can come here, a wave can go here. So if I talk, I'll not be able to receive the signals from the same wave. The radio waves will collapse, and the signals will be lost. It can't be full duplex, but there are some technologies available like OFDM and all, which is like out of scope of this particular session, where we can have full duplex. A transceiver will be able to transmit and receive data at the same time, right? So this is another big technology behind 5G. So we don't have much time, so let's go very quickly how it affects our life. I think that's one very important thing, very fantastic thing to watch, right? I'll just skip this one. As I said, this is the first thing that we will all see in our family, right? Our home will become connected. You'll have smart home. Everything will be connected. You can see bulb, everything, temperature, everything will be connected. Your fridge will be connected to, the service provider. The fridge will be connected, to the Amazon, just for an example. And if something is over, Amazon will get notified that, the milk is over, and, tomorrow the milk will be delivered. We'll think that it will not happen, but it's already happening, right? It will be like that. Everything will be connected, and your information will be shared with the service provider if you want to, and then and you will get benefited out of that. The next thing is factory IoT. Factory IoT means the factories all will become machines, where robots will be connected, and robots will start doing anything. You don't need to be there. Everything is connected. You will not see wires, things like that, and it will be connected to the intelligent systems behind it, and they will do the task. So all factories will be becoming IoT factory. Sustainability, everything, as I said, right? Water management, energy management, climate control, smart lighting, everything will be connected. It is called smart cities, right? We have smart cities now, but it's not actually smart. We'll have, when it becomes actually smart, right? The water management system will be connected to all the homes, where it will start saying, when you're using more water, you will get a call from the government saying that you're using more water. You should not use that water, because it will impact the entire city. Please use this water. Everything will be connected. The energy management, climate control, smart living, everything is connected. Logistics and shippings, where we want to ship one parcel or anything, logistics, right? It will be connected. You can track it in all the way that you can. It will not be just when it is shipped. It will be, you can track it from the build to the manufacturing to the supply chain, everything. And the moment that you ordered, you will be able to track, because everything is connected, right? You will start seeing smart farming, where the sensors will be connected to the plants, and then when the plant needs water, it will automatically starts watering the plant. And when the fruits gets ripe, right, it will automatically, inform, the concerned people, and then, it says the fruit is ripe, and then come and then pick it. It will, everything will, the soil, the conditions of the soil, the nutrients in the soil, all the minerals in the soils, everything will be monitored, will be having a lot of sensors, and everything will be connected. And this smart farming is already implemented. It's already there in some part of the world with 5G. Okay. Healthcare. Healthcare is a very big, use case for healthcare, as I said when in the beginning, right? You will start seeing there is no need of physical contact between the surgeon and the patient. You will be here, and the patient will be somewhere else, and you can actually do operations, whatever, right? It will be that fast. All these things happens because of one or the two features of 5G. Like, there is no latency, it's high speed, there is no very less power, efficiency, and things like that, right? So the healthcare and mission critical applications will be the best ones which will be using 5G. Autonomous driving, the cars will be talking each other, the vehicles will start talking each other, because it's all connected, and there will not be accidents, because the other car, if it slows down, the behind car will, knowing that it slows down, it is slowing down, and the car will start slowing down, and you just need to sit and relax, and you'll get into the destination. So autonomous driving, right? Everything will be connected. Drone operation, everything. If you see now, right? If you order something in Amazon, somebody comes and then delivers you. Now, after some time, you will start seeing drones getting delivered your packages to your home. You will not see people coming to your home and then delivering the packages. It's all will be controlled by drones. It's already there. It's again in the experimental purposes, already implemented. You can see drones and all in the firefighting area. You will see drones in the police department, where instead of mobile police, all those things will be drones, and then it will come and then help you, or it will come and then put water on the fire, public safety, disaster recovery. Everything will be drones, and it will be all connected, right? Security and surveillance, right? That's one big thing about 5G, where everything is monitored. You are connected, and obviously, it can be used for all your security and surveillance purpose. If your heart rate is going low, you don't need to worry about, because the heart rate low is already sensed by the hospital nearby. You will only got to know by them coming to your home and then taking care of you. So because you will be having wearable devices, and then that will be monitoring your heart pulses, and you'll be taken care. So surveillance, security, health systems, everything are the applications of 5G. I think we are out of time. I think it is 7:53. I have one slide which I don't want to take because it takes more time. Let me go into straight to here. Final thoughts. 5G is one of the most sophisticated wireless technologies we have ever developed so far. You can't compare with 4G. We all should not think that it's just another version of the wireless. It's just completely different. It will revolutionize the entire wireless network. The social economics impact of 5G is yet to be analyzed. We don't know at this time what will be the applications of 5G. I just mentioned a couple of applications in our daily life, but the application, as I said, when the electricity was invented, right, we don't know what was the applications, right? Similarly, right, when 5G is already started implementing, right, it's limitless, it's endless, right? So that's the final thought. And there are some limitations which we'll talk if we have time in our Q&A. Over to you guys. I'm sorry I took more time. I think we have some 5 minutes. I can actually be here for another 5 minutes, so maybe 10 minutes we can talk for answering your questions. Any questions?
Yeah.
Okay. Yeah, hello.
Yeah. Am I audible?
Yes, you're audible.
Yeah. Thanks. Thank you, sir. I'm just a guest listener. I was a speaker here last week. My name is Tom. Sorry, I could join only
Hi, Tom.
around. Yeah, thanks. I could join only in the middle, and I could follow from there. And sir, your speech was very, very good, and I'm excited to hear about the limitless possibilities of 5G technologies. And it is really, really amazing because as a person who was tracking these developments for last several years, I know where we came from. You mentioned about the old type 2G cell phones and the current where it is going to take us. So I have some observations. Maybe you could answer for the benefit of the crowd here in this team right now. You just mentioned that this is millimeter waves, where I think where this microwaves stop, right? Microwaves.
Millimeter wave. So it
Yeah.
starts from 27 megahertz to 300 megahertz.
Yep. So
27 gigahertz to 300 gigahertz. Sorry, sir,
yeah,
please continue.
yeah, gigs. So my question, will it not present its own challenges, because this will tend to behave same as microwaves? So you can't use cables for carrying this. You need to have hollow guides, right? So how they will handle this thing in the towers and inside the mobile devices?
So yeah, good question. So the thing is, as far as I know, this millimeter waves, the problem with millimeter waves is it will be part of the negatives of 5G, which I didn't touch actually, but I can talk about it. Millimeter waves will be having very less travel time, where if you have a small building or even rain, right, it will get obstacled and your signal will be lost. Like any other microwaves which works in that particular range. So we will not actually use the entire millimeter wave which goes up to 300 gigahertz. We will be using from 27 gigahertz to 100 gigahertz, which will be only for 5G technology, and the rest of the frequency millimeter wave spectrum will be used for the rest of the applications. That's one thing. And to answer your question about the antennas, because of the travel time of the millimeter wave is very short. You have to have very dense antenna system in a specific, for example, 1 kilometer square area. If you have one tower in 4G, you may need to have 300 5G antennas to cover the entire spectrum of 1 kilometer. Just giving some examples. I remember it was like 20 times number of antennas. So if it is one tower, you need to have at least 20 antennas to cover the same location, same area. The problem with it is it involves a lot of cost. It involves a lot of infrastructure. But what I think what will happen is, say for example, if you want to have a Wi-Fi system in our home, we actually buy the access point and we have the Wi-Fi, right? It will come to that point where we all will be having our own, or maybe one association of an apartment will have its own 5G antenna, and it will receive the signals from the base station, and it will circulate the signals within that particular apartment. So it will be that dense antenna system, which we call it as distributed antenna system, DAS, in 5G.
So these antennas may tend to be kind of arrays, or is it still the dipole kind of old style?
It will be arrays. One antenna will be having at least some 100 small cell antennas.
Yeah, I thought so. And few more points I just want to share and ask questions at the same time. You said this is beam forming, that is very interesting, and it is highly full duplex, which other 4G or 3G also may be having, and that's interesting. And you mentioned IoT, the impact on IoT. Yeah, it's very interesting. I mean, actually, you could talk one more talk on that later, the IoT itself. And we are talking about Industry 4.0 and even 5.0. So it will have a big impact, no doubt. Maybe you should enlighten the students group later on also. And that will be interesting. And my other question will be, sorry to ask so many questions. My other question will be, can this 5G spectrum or similar frequencies be used effectively for, or better used for wireless charging as well? Because it carries more charge, more power. Did I break off? Did you hear my question?
No, I just lost it between, I think, what you're saying. Maybe the last point I didn't hear.
I'll repeat.
Can 5G spectrum can be used for wireless charging?
Yep. 5G spectrum, can it be better used for wireless charging?
5G spectrum cannot be used for wireless charging because of just because the charging will take the frequency of electricity is so low, it will be very difficult. Now what is happening with wireless charging is not with respect to microwaves. It's based on induction, where the charge the electricity is actually conducted wirelessly another through induction. So you can see the current mobiles and all where they call it as wireless charging. It's based on induction and not on the microwave technology.
Yeah, I understood. Thanks, Dan.
I hope I answered you.
Thanks. Few more points, sir. You mentioned also smart cities, and it is coming up in a big way. My employer, that is Schneider Electric, we are into smart cities. We have got several contracts, and we are also working with these government agencies for some part of this smart cities. So that is very interesting. And these are not dreams; these are all happening. But as you said, it may not be in full-fledged way, but it's already happening in India, some cities, smart cities. Then, as you said, RFID kind of kind of usage will be much more meaningful by using this spectrum when it comes. And you said smart farming. That will increase the possibilities of precision farming, and thereby a lot of control can be achieved in farming, in high-value cash crops at least. Then you also mentioned very aptly that telemedicine, it can be revolutionized, and it is very, very true. Very, very true. Sir, it was very informative. In a short time, you have touched upon a lot of things, and it was very informative. And I have a final question to you. It seems that you have worked in this radio engineering a lot. So do you have a ham radio club in your college there?
No, sir. I'm actually in the I'm into telephony network, but on the IP area, where you have the UC communication, right, unified communication, and all the IP world. So my work is mostly into the IP telephony area, and not on the actual 2G, 3G, 4G, 5G area. But this is my interest, and this is a little bit, it will be colliding. The technologies are colliding. So I know these technologies as part of my reading, and it's kind of understanding what's technology and all. But I to answer the question, I don't have the ham radio thing, but I'm really interested to have one, and then to have a network there. I know one person who is having a station with ham radio. Maybe we should connect, and then I can give you.
Yeah, we should do. The point why, I mean, in the colleges, if they have it, the children, the students will get a lot of hands-on experience, and they can actually discover the soul of this communication technology and this. Otherwise, they will be learning a lot of technologies by heart or in theory, and they won't have a chance to learn it by practice. So I remember when I was studying, my institution had a ham radio station, and that gave a lot of chance to do it practically. And then they will discover what we are talking about, the history of communication and what it can do for the future. So thanks for the time. Sorry to have taken a lot of time, and it was wonderful.
Yeah,
thanks.
I think that's a very good. That's a very good suggestion, sir. That's a very good suggestion. I think people hearing as people hearing this, Tom sir has told one very good suggestion. I think you should consider, having that, and then learn the technology by actual hands-on. That makes really interesting, and learning more to it. Reading and getting understanding through books might be a good idea, but but I think we have better ways by having hands-on sessions. Yeah, thanks for the session, Tom sir.
You're welcome. I'm happy to suggest. Back to you. Thanks.
Yeah. Yeah. Anybody interested to hear the frequencies and how we started and all? I can spend some time. Let me know, or we can. I think we are already 8:05, right? So
good evening.
It's up to you guys. If you. Good evening.
So I would like to know that something regarding that the last things, the range of frequencies. I was just going through the ham radio thing and all. So I have heard about it, and my nearby Autozona is also using ham radio. So just was looking on the frequency ranges and all. So I'm not into it. So if you could spend a few more time to explain that, it will be better.
Yeah, I can spend some time here. We call it a cell network, or I was expecting that some people will ask why we are calling cell. What is the reason behind, right? So when it started from 1G, there was one tower, and that one tower will be catering into some users, right? Say for example, one user will be having one frequency, and the second user will be having second frequency, like that, right? So the design of if you see this cluster size equal to 4 and the picture there, you can see that in a bold line there is a cell, right? 1, 2, 3, 4. The cluster size is 4 cells, and 4 cells means there will be one antenna in that 4 cell, and that antenna will be able to cater to 4 users in that particular area. So that means 1, 2, 3, 4 users can use that antenna to make calls. Anybody outside that cell will be connected to the other cluster, which is in 4, right? So that means you will have in a big area, you'll have multiple antennas. I'm just giving 4 as an example. Actually, 4 is a very less number, but just to give an example, right? So if you take a big area, you'll have multiple antennas, towers, and that towers will be used for communicating that particular cell cluster, right? And the moment that particular user goes to beyond that cluster, he will start getting signals from the next tower in the second cluster, and the communication continues, right? So now the question happens, when the user goes from one cluster to the other cluster, if the first user is using frequency 1, if he keeps on going, right, and to the next cluster will have interference with the frequency with the frequency of the next cluster. So there will be more interference in the edge of the cells. To avoid that, if you can see in the diagram, this was the methodology used, where inside the cell inside this is one cluster. Inside the cluster, there was a perimeter defined, and in that perimeter, all this frequency 1, frequency 2, frequency 3, frequency 1, 2, 3 will be used. And when the user goes beyond the space, right, only frequency 1 will be used for that, from that particular antenna. So what it means is, if a user is here, right, if a user is here in the next cluster, he will not have the same frequency F1. So the perimeter will be always having unique frequency when you travel from one cluster to the other. So so that was the method. All those things I'm talking about is history. This is no more valid. We have different ways. It's no more frequency division multiple access, which was the case in 1G. Now it's like TDMA, where time division multiple access is happening. Now it's code division multiple access, CDMA, and orthogonal. There are different ways. This frequency division multiple access FDMA is no more. I just brought this as a backup slide to explain you how the cell concept came and how frequency was used, in early stages. This is an application where you can use it for in your ham radio, how the frequency is used in a particular area. Hope I made sense.
Yeah, thank you. Okay. So.
Okay. Any further questions?
Sir, we have few questions in the chat box. I will just read it out to you.
Okay. Sure.
Shyam Balan has asked you to please mention about its bad sides.
Oh yeah. Sure. Of course, let's look into the limitations. As when Tom sir was talking, right, we did touch upon the limitations. The big limitations or the disadvantages is the higher cost in manufacturing of the precise hardware, because as I said, the antennas will be very, very, very small, minute antennas. A big box will be having 300 antenna grids, or they call it cells. So it will be very small, high precision. Hardware needs to be manufactured. So obviously the high cost will go higher. But this will come down when time goes by. But at least initially the cost will be so high in manufacturing those hardware. The second limitations or disadvantages is the extremely high frequencies will have attenuation, significant attenuation. We talked about it, right? If there's a tree or if there's a building or if there's just a rain happening, you will lose the network, because high frequency will not be able to travel through buildings. It's like light. When you put a torch light, right? When there's an obstacle, the light will not go high, right? Because light is actually in the other spectrum. So similarly, like high frequency spectrum will not be able to travel through objects. So that's a limitation. But now what happens in 5G is that limitation we'll be using as an advantage by creating a distributed antenna system, and hybrid antennas where you'll have multiple antennas in all the places and things like that. So yes, it is a limitation. The penetration power of millimeter waves through objects such as concrete walls is very less. As I told, this is the same thing. And the interference with oxygen and rain at higher frequencies, and which again introduces this all are limitations of the radio wave technology. There is no limitation on the software side or on the virtualization. If I go more on the 5G, it's all SDNs and NFVs and all. It's beyond the scope of this session, but it's all network slicing happening in 5G. I don't think there is a limitation there, because we always can scale up. The limitation in 5G is on the radio side, which I already talked about here. I was exploring about some disadvantages about the health problems in millimeter waves. I think Tom sir can talk more about it. But when I was researching, right, I was getting contradicting viewpoints, and there is not much enough evidence to say that there is a hazard issue or health issue because of the millimeter waves. That's why I didn't bring that topic here. But that is also a big discussion in the internet world. Will 5G impact our health, or the world as a total for trees and all the ozones and things like that? I'm not sure about it, but there is a discussions happening on that front also.
Yeah, right, sir. It's still a debatable topic, so we can't conclude whether it is interfering with the health or not. It's a big topic, still not resolved.
Yeah. Any questions? Okay, if we don't have any questions, I think because of the time factor, I'm interested to talk more, but I think we should respect the time of everybody. Let's stop here, and maybe we can talk sometime later about all new technology. Maybe we can dive into one of the topic here and then talk 1 hour about that particular area of technology. But I would like to thank you, GCWAB, GCW, IEEE student branch wing, and all the audience here to listen to me for last one hour, and then giving me time to discuss, and then it's an honor and privilege for me to talk and then spend some quality time with you guys. So if you want to catch me, please, this is my this is my email ID. You feel free to catch me on my email. Yeah. So over to Arjun.
Yeah, I think we have done. Over to Anu or Shabir sir, please. We will see you next week with different session, different topic.
Hi, good evening.
Okay.
Thank you, Shameer. Thank you, Arjun, and thank you, GECW, for a series of sessions, webinars continuing. On behalf of Alumni Association and IEEE Student Branch, I would like to convey my thanks to all of you. So we'll be having one more next session, I think, by Akhil, isn't it, Arjun?
Yeah, right.
Okay. So all the participants also, I could see Elisa just now left, Professor of GC Thrissur. So anyway, thank you all. Over to you, Anu.
Okay, so we are, as always, we are leaving a feedback form here. These participants, please do fill in the form and let us know the topics you're interested in. So on behalf of IEEE SB GECW, I express my sincere gratitude to Mr. Ahamed Shameer, Engineering Manager at Mitel Communications, for taking his precious time for us. The session was indeed edifying. Thank you so much, sir, for such an amazing session. And thank you so much, Dr.
Sure.
Tom George, for being with us here. He had taken the previous session. Thank you so much, sir, for joining us today. Many thanks to Mr. Arjun